Good morning, class. Hope you all are doing well today. We're in the middle of the week, so we're halfway done with another week here at school. But we're just going to begin with the word of prayer and then have our 10 minutes to work on our student booklets. Make sure you're getting those in. Those are easy grades that can affect your grade quickly. Remember, because they're worth 2 grades every week. Okay, so if you're doing half it, you get a 50. Okay, you get 2 50s. If you get 100, 200s. If you get 0, 2 zeros. Okay, so make sure you're keeping up with that. But let's pray. Remember, if you have any prayer requests, you can always write them down. You don't have to put your name or anything if you don't want to, or you can just let me know when I'm down there. But let's pray, and then you guys can work on that. Dear Father, Lord, thank you for this day. Thank you for the beautiful weather you've given us. Thank you for the health that you've given us, Lord, that we are able to be here and healthy, Lord. Thank you for the possibility for Calvary to be open, Lord, for us to be able to be here at school and enjoy company of friends, be able to see and learn in person. For the most part, I know everything's not quite back to normal or how we're used to things, Lord, but thank you for allowing us to have an opportunity to grow and maybe try something a little different. Please help all the kids today, Lord. Give them wisdom, give them strength, give them comfort. If they're going through any problems or heartaches, Lord, please just give them peace and show them and remind them how much you care about them, Lord. Please bless them as we go through Bible here in a couple minutes, and as they're doing their booklet, for them to be able to find something that they can learn and be able to apply to their life today, maybe this week. Please help the rest of the day for any tests they might have. Give them the wisdom and the remembrance of everything they studied or we talked about in class. Please bless everyone's day and allow us to just do the best we can in everything we do. In Jesus' name, amen. All right, like I said, you're going to begin working on your student booklet or workbook for about 10 minutes, and then we will be right back. All right, welcome back. Hopefully you were able to use that time wisely to get some of that done, some of the reading done, maybe memorize the verse a little bit. We're going to recite the verse real quick, and then we're going to jump right into our notes. But we have John 1 through 3 this week. Hopefully you're looking over that every night. John 1 through 3. I'll try to make that fill in the blank so it's a little bit easier. Okay, but there's a lot of good truth, certainly applying what we're talking about this week's lesson. Okay, so John 1 through 3. If you want to open your Bibles and pull that out so we can recite that together. Okay, either read it out loud or to yourself, but just make sure you're following along so you can learn the verse as well. We have John 1 through 3. He says, "In the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things were made by Him, and without Him was not anything made that was made." Okay, I'm going to read it one more time. Hopefully you're following along. This could be a help. I'm just looking at it a little bit if you're not looking at it any other time, so we can get a good grade on that tomorrow. So John 1 through 3. "In the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things were made by Him, and without Him was not anything made that was made." Okay, just again talking about how obviously God has no beginning, has no end, but He has no beginning and end. But the Bible also has been the truth for all time. This allows us to know that the Bible is God's word. It's nothing else. It's not man-made. It is the Bible. It is God's words. But if you want to pull out your notes, and we're going to jump right into that. Yesterday, or we've been talking about this week, we talked about the size and the location of Israel, and then we talked about the different geography, the climate, the crops, right? The difference in what pertains to Israel. Yesterday we talked about the political division, how we have all these different areas, main two areas of Israel, but also the different Roman provinces. We talked about those. And then we had, with the Judea and Samaria, then we have Galilee and Perea, Iturea and Trachonitis, which is northern Galilee, and then Decapolis, which is a combination of 10 Greek cities. Today we're going to be talking about the geographical divisions. The geographical divisions. Okay, Israel is comprises 6 distinct geographical areas. Okay, there's 6 of them. They're all right there. Okay, we have 6 different distinct geographical areas. Okay, the first we're going to talk about is the coastal plain. We have the coastal plain. This coastal plain stretching along the Mediterranean coast to Mount Carmel. Okay, the only major variation in otherwise straight coastline. This coastline ranges from 6 to 20 miles wide, and it lies the fertile farmland of the coastal plain. This area contains some of the richest soil in the world. In fact, a large part of the most desirable land in Palestine is in this narrow area. Okay, again, so this is going to be this area of rich soil. You want to remember that. The coastal plain is an area of rich soil. Because of the water, it makes the land not hard, it's soft, great for planting. It allows things to grow very well and have the right nutrients. Okay, that's the coastal plain, the first one. The second one we're going to talk about is the Shephelah. The Shephelah. I actually don't know how to say that. I think it's Shephelah. That's how I was reading it last night while reading. But the Shephelah, like shepherd or Shephelah, one of those two. We have the Shephelah. This is between the coastal plain and the central hills. It's a series of foothills, okay, called Shephelah. This area corresponds to almost any rolling hills section of North America, okay? So that's how we're to remember it. The Shephelah is the rolling, or are the rolling hills. It has low hills ranging from 500 to 1,000 feet in elevation. Okay, so just small, not quite mountains, but maybe small mountains or big hills. This area is particularly, wow, I'm struggling. Particularly, I'm struggling. It's all right. Suited for growing olives, grapes, and grain, and for pastoral farming activities. It once served as a buffer zone between the Philistines, who lived on the coast, and the Israelites, who lived in the mountains. It was a much disputed area. Okay, so the Shephelah is this area of low-ranging mountains, maybe, or hills, maybe some valleys. We're going to remember it by calling them the rolling hills. This is the area that was in between, in Bible times, in between the Philistines and the Israelites, okay? The Philistines were located like on that coast, maybe part of the coastal plain. They were located there. In Israel, it was more inland. And this is the area kind of like that in-between median zone. That's the Shephelah. Then we have the Cisjordan Hills. The Cisjordan Hills. These hills are commonly associated with Israel's history. Most of Israel's cities and people are located in this area. The hills range from 1,500 to 3,000 feet high. Okay, so these hills are a bit bigger. The elevation increases to the north. The hills become the Lebanon Mountains in northern Galilee. The mountains rise to an elevation of about 10,000 feet. Okay, so we're going from, we have the coastal plains, right off the water, they get good nutrients, and then we're going to a little bit higher, these rolling hills, and then we're getting into like this mountain range, these Cisjordan Hills, okay? They go from larger hills all the way to the Lebanon Mountains, which is around northern Galilee, and this has an elevation of 10,000 feet. Okay, we're going to remember this is where Israel is more located. The cities are going to be not quite all the way up in the mountains, but we have a lot of cities pertaining in here. Remember northern Galilee, so Galilee, is going to be there. So Cisjordan Hills, we're going to remember as Israel's cities, or where they would be located. The next one is the Jordan Valley. Okay, we have some notes on the Jordan Valley, so you might want to write some side things on the side. But we have lots of stuff about the Jordan Valley. Okay, the Jordan Valley stretches from the Sea of Galilee to the Dead Sea. Okay, so it's a long, large valley. Okay, all the way from the Sea of Galilee to the Dead Sea. However, it is only a small section of one of the most remarkable geographic depressions on the earth. In its full extent, it is known as the Afro-Arabian Rift Valley. This system is the most important continental rift system known to modern geologists. There's two continental plates that meet along this rift, with the land to the east of the rift moving northward about 1 centimeter per year, and the land to the west of the rift drifting south about a half to 1 centimeter a year. Okay, so it's on a rift. This is an important valley. It's known as the Afro-Arabian Rift Valley. You could write all that stuff down. It's also stretches from Sea of Galilee to Dead Sea. The rift begins in the Amanus Mountains of southeastern Turkey and extends southward through western Syria, where it is known as the Gab, or Gahab. It's G-H-A-B. Okay. Thence it continues southward through Lebanon, where it is known as the Bekaa Valley, into Israel. Okay, so it's stretching all this land, all the way from Turkey to Lebanon to Israel. And in Israel, it's known as we've already said, the Jordan Rift Valley. It continues down through the Gulf of Aqaba, or Gulf of Eilat, on the Red Sea. There, it parallels the Red Sea all the way to Ethiopia. Okay, so all the way, we're going into Africa now, where it splits. An eastern rift extends to the Indian Ocean. A western rift penetrates Ethiopia, Kenya, Uganda, Tanzania, Malawi, and Mozambique. Okay, this covers a total of 4,000 air miles, or 1/6 of the Earth's circumference. Okay, those are going to be some things you probably want to write down about it. Okay, all to say, this is a large area. It's a large rift, a large valley. Talking about this rift, the Jordan Rift or the Afro-Arabian Rift, this single rift is responsible for creating the Sea of Galilee and the Dead Sea in Israel. It also is responsible for creating the lakes Rudolph, Albert, Edward, and Victoria in West Africa. It is responsible for separating the island of Madagascar from the continent of Africa, this large rift, okay? So from this valley, we have this rift because it moves every so often, every year, just barely, but it adds up. And this has created these separations and these different bodies of water throughout, all the way from Israel, all the way down to now, West Africa and Madagascar. Due to the constant moving of the two continental plates along this valley, between 200 to 300 earthquakes occur here daily. Okay, pretty crazy. There's a rift here in California. We get earthquakes from it. We don't always feel them. Okay, imagine having 200 to 300 of them. Maybe not all, obviously not all severe, but having that many daily. Along the distance from the Sea of Galilee in the north to the Dead Sea in the south is only 65 miles in a straight line. The Jordan River winds like a serpent through the rift for more than 200 miles between the 2 points. The Jordan River ends where its waters flow into the Dead Sea, which is about 1,292 feet below sea level, and is 1,300 or 1,300 feet deep. About 6 million tons of water flow into the Dead Sea every day, but the water has nowhere to go. The Dead Sea has no outlet. That's why it's called the Dead Sea. Okay, there's water going in, and just like a lot of times we have, right, maybe some rivers and things go into this sea or this large lake or body of water, and then that goes into the ocean or goes into another body of water, right? The Dead Sea has no outlet, okay? There's a term for it. You can look it up, but it goes into the Dead Sea, and that's one reason why it's called the Dead Sea. It goes there, and it's done. It stays there. It will never leave unless it goes into the soil or evaporates. The Dead Sea has no outlet. Because of the intense heat of the area, the water evaporates very rapidly. Like I was saying, it goes here, it evaporates, it gets soaked up into the soil, okay? Leaving behind about 25% solids, okay? It's also Dead Sea. I mentioned this before. It's known for its solid salt or like chunks of salt or erosion of salt on the rocks because this water is so dense. By contrast, normal ocean water contains only 4 to 6% solids. Okay, so normal ocean water only pertains 4 to 6 solids, where the Dead Sea pertains 25%. So you can see the crazy difference there. And this makes the Dead Sea one of the wealthiest mineral deposits in the world. Okay, and this is all because of this Jordan Valley we talked about. The Jordan Valley and then the Afro-Arabian Rift Valley, which is another name for it, which in that valley we have the Jordan Rift, where it moves just barely every year, but this has created different bodies of water, created separation of Madagascar from the main continent of Africa. Okay, this is all from in the Jordan Valley. Okay, the last geographical division we're going to talk about is the Transjordan Hills. The Transjordan Hills. As the name implies, these hills and mountains lie on the other side, east, or of trans, which means across, right? East or trans, which means across. So it's Transjordan Hills. We have the Jordan Hills. Okay, we have Cisjordan Hills. We have So now we're talking about the Transjordan Hills, which is east or across from the other ones of the Jordan River. Technically, the term means the side opposite from the viewer's perspective, but it is generally used to refer to the East Bank area. This area is a high plateau that rises gradually from the north, about 1,320 feet high, to the south, higher than 3,940 feet. Okay, so this is the Transjordan Hills. It goes from 1,320 feet to 3,940 feet. Okay, we're going to remember that, those measurements for the Transjordan Hills. Okay, just to give you a perspective of all these geographical divisions, okay, we have, here's like how it is, okay? So obviously it's not like a high-def map, but try to follow. So you have the Mediterranean Sea, right? So you have that outlets to the ocean, and then you come up onto this coastal plain. Okay, so you have the first one, the coastal plain. We talked about this is going to be that rich soil. The Philistines inhabited this area for a long time, right? We have the coastal plain, which is rich soil. Okay, then we had the Shephelah. Okay, this is the rolling hills. Okay, so we're just continuing on. You have the coastal plain, rich soil, and you're going to be going into these small hills. You can't really see them, obviously, but there's going to be just these small hills, not really mountains. This is that in-between division that separated the Philistines from the Israelites. It wasn't super inhabited, but they were there. Next, you have the Cisjordan Hills, as we talked about. These are more getting in that mountainous region, right? Where we have all the way from 1,500 feet to 3,000, all the way to 10,000 feet in the Lebanon mountains. Okay, these are going to be mountainous. We're going to see, as you can see, Jerusalem is located on the backside or middle of these towards the downslope. So you're going to have those mountains a little bit, and the Shephelah separating the Philistines and the Israelites. Okay, this is the Cisjordan Hills. Then we have that Jordan Valley or the Continental Rift, right? This is kind of that area in between the Cisjordan Hills and then the Transjordan Hills on the other side, right? The other side, and then you have Cisjordan Hills where the mountains and stuff. It's Jordan Valley, which has created the Dead Sea, and it has those two rifts which affect all the way down to Africa. This is that Jordan Valley. Okay, all those things we just talked about. And then lastly, we had the Transjordan Hills. The Transjordan Hills. And then this is, again, just a trans or across the valley. And this is just another little mountainous region. Smaller, but from 1,320 feet to 3,940 feet. Okay, that's all we're talking about today. Again, remember this week's lesson is just a lot of information, giving you the setting of Israel, maybe the setting and area where Jesus was. Obviously, we can't give you too much because we're not there, but it kind of just shows you the mileage. See, all from even just all the way from the Transjordan Hills to this Mediterranean Sea, which is almost the whole area, right, is only about or around 90 miles, okay? So it's not that far if you think about it, given there are no cars, okay? You're going by foot, horse, maybe later on chariots, okay? So you got to put it in that perspective. There aren't cars, so it did take a long time to travel, but this area is pretty small. Certainly compared to our states, as we've seen, the size comparison. Okay, there is no homework tonight. That's all we're going through for notes. You're going to want to review for Bible. Remember, we have our verse quiz tomorrow, John 1:1-3. Somebody fill in the blanks. It shouldn't be too hard. Okay, try to help you guys out with that. Also, we have our booklets due tomorrow. Make sure those are done. If you don't have some blanks, try to do the reading. Make sure to try to find all those blanks. If you don't have all of them filled, remember I have to mark you off for some. But make sure those are done. If you have any questions, distant learners, let me know. Thank you, Christian Halsey, for being here. Hope everyone is doing well. Let me know if you need anything. Christian, I'll send over that test 2 for government here in a second, so you can have that. But hope everyone's doing well. Hope that was a help, giving us, remember, a lay down and perspective of this nation of Israel, the area of the time of Jesus in the book of John, to give us a little more insight. But hope you guys have a good day. That is all. Hey guys, I know it's the break, so for government, hopefully distant learners are listening as well, but for government, all we have is our test today. So I'm just letting you know we have our test today. Distant learners, if you don't have it, I'll send it over to you right now. I don't think you have it yet. I tried sending it, but it didn't go through. So I'm going to send it again just to make sure. And then students, I'll be down there in the classroom by time of class to hand out your tests, and you guys may begin. So study. If you have those study sheets, you can keep them away right now. And then you'll pull it out when you turn in the test. So I'll be down there in a couple minutes. We'll see you guys soon.
All right, welcome to chemistry. Go ahead and get out your supplements in your textbook. In your supplement, we are on page 22, and in your textbook, we're on page 108. Supplement page 22, textbook page 108. Let's go ahead and get started this morning with electron configuration. So this is where I left off yesterday when we ran out of time. And so what I want to do is I want to take this opportunity to re-go through it, and then we're going to go through Lewis structures, and then tomorrow will be a work day. So those of you in the classroom here at the Distance Learning Center will be able to ask questions or just take your time to practice and work on it. And then the homework for this section will be tomorrow night. And then Friday, you'll have quiz 7. I know the numbering isn't the same. My quiz numbers always match the chapter numbers. Okay, so if anyone was wondering how we suddenly got to quiz 7, that's why, because it's over chapter 7. And then something else. Oh, and then we'll begin 8.1 on Friday. Okay, so that's the idea. We'll give that quiz, and then we'll give 8.1 on Friday. So that's the idea. So we're going to go through electron configurations first. So again, be on page 22 of your supplement, be on page 108 of your textbook. And let's consider electron configurations. If we're talking about a neutral atom in the ground state, these 5 principles will help us create the electron configuration. These 5 principles are listed there on page 22, so I'm not going to keep bringing it back up on the screen. You guys have a supplement. I have everything there listed for you. It's also on page 108 of your textbook. If you look on page 109 of your textbook, I believe that's just across the page for you guys. That's the problem with digital, I don't know. But you see table 7.3. Okay, table 7.3, and that gives you the first 20 of these electron configurations. So we're going to go through here, and we're going to discuss how this works. We're going to discuss in a bit more detail how to determine an electron configuration. So I have here the periodic table. Okay, and I just realized I don't have my pen color correct. If I try to write in yellow on white, it's not going to look good. So we'll just switch those. All right. So as I look at this periodic table, I know a few things right off the bat. I know, first of all, that this, okay, something is not right with my tablet, and I'm going to go through and fix it, because that did not feel right. Tablet, map to monitor. Yeah, it's not set correctly. Cool. That feels a lot, okay, there we go. Now, there we go. All right, so this first 2 here are the s block. Keep in mind the s orbital is a sphere, and it's our lowest energy sublevel. Okay, so this right here can only have 2 electrons in it. The next sublevel that's available within an energy level is the, oh goodness, which letter is it? P, the p block. Now the one exception is this up here is still in the s block. Okay, that's it, because helium could both be in slot number 2. It could be in slot 18. It kind of acts as both, and we'll discuss why more later. Hydrogen, same example. We could either have it in slot 1 or slot 17. There's reasons for why they are where they are, but they're kind of our exceptions. Okay, and we just know that, and we live with it. All right, so we have the s block, we have the p block, then we have the d block. The d block is this in-between region. Okay, so this is the d block. Now, the d block, and there's nothing about the periodic table that makes this happen. It's the reason why elements behave the way they do and why they are where they are on the periodic table. It's the other way. They're in this spot on the periodic table because they have these properties, not the other way around. All right, so this right here is the d block, and this will always be -1 on the energy level. So if it's in row 4, it's in energy level 3. Then down here, this 2 group here is our f block, and this will always have a -2 to its energy level. Okay, so in row 6 you're actually at 4f. In row 7 you're actually at 5f. Okay, and this is actually how I work with it. Now they go through and work with it the other way. We gave you guys this diagram the other day. I know it from the periodic table. Okay, because the periodic table is your friend in this class. The more comfortable you are with it, the better off you'll do. And just overall, again, the periodic table just kind of has it laid out really nice and neat. Again, it so happens the periodic table is laid out that way. In reality, it's because we figured out all this, okay? And that's what actually causes the periodic table to be laid out that way. Again, we'll discuss it more when we discuss the periodic table. I'm kind of I'm only slightly putting the cart before the horse, although just now imagine if we had done chapters 3 through 6 before doing chapter 8. Okay, we're getting through chapter 7 without chapter 8. Okay, so just bear with me, and then we'll come back to those other ones later. So anyway, just mentioning that. Okay, so we have that pathway there. Again, that slide that I was just showing is available on Google Classroom. So if you didn't get it all down, you guys can get it later. All right, so here is this. So let's pick an element. Because I didn't even get to the shortcut yesterday. Oh, whoops. Okay, I have to remember. You guys cannot see. Wow, that barely fit. Okay, cool. So I'm blocking that notation. Okay. So I will just, no. Remove that. And pen tool. All right, so helium is also in the S block. Okay, there we go. Now you guys can see it, and then I'll just keep in mind there's an imaginary line right about here. Actually, I'll just, okay, I can't go above that. You guys can't see it. I purposely drew it where I am. All right, so let's go ahead and talk about one of these. Let's pick an element. I'm going to pick carbon because we keep picking on carbon, so why not? So carbon is right here. Okay, so I'm going to start at the top left of my periodic table and fill in all the energy levels I can until I get to the one that carbon's in, if that makes sense, or the last electron in carbon. So, because carbon has 6 electrons, so I have to count for all 6. So the first 2 are in 1s, so I would write 1s2 because 2 can go in there. Okay, so I know I'm using 1s2 because I'm not in the first row. In the second row, well, I have the 2s block. So, and I'm past that, so it fills in both in the 2s block. And then, as I continue on, now I'm in the 2p block, but I don't take up the whole thing because carbon is not at the end. Okay, so that means 1 got placed in the 2p block, 2 have gotten placed in the 2p block, so we have 2p2, and 2, 4, 6 electrons later, sure enough, there's my configuration for carbon. Now, there is a shortcut that exists and is very convenient when it comes down to electron configurations. Did I not show you guys? Okay, either it's not in the book or it's not in the book yet, and that may be a yet thing, because I remember this distinctly being in here. Okay, well, I'm going to teach it to you now because I don't like it when people don't just say shortcuts. I can always start at the end of the previous row. Okay, so right here, everything up through helium will be the same. So I can just put helium in brackets and then fill in after that. Now that may not have saved us a ton of time. However, let's consider lead. Okay, so let me get, all right, let me remove all this. No, I got too much. Delete that. Delete that. And delete that. Okay, let's consider lead for just a moment. Okay, as we look at lead, it's all the way down here. It's number 82. As you can tell, this is going to be fairly long. Okay, and I'm going to do it mostly because I think it'll help it click. All right, so let's do this. We have all of group 1 done, so 1s1, or 1s2, I'm sorry. I'm going to take multiple lines. Normally you would just keep going, but I don't have a lot of space here, so let's keep moving. The 2s block is full. The 2p block is full, so we have 2s2, 2p2. The 3s block is full. 3p block is full. The 4s block is full. Okay, again, you would just keep going. Then, keep in mind, this is the 3d block. Okay, it's always -1. So we get the 3d block, which has a maximum of 10, I think, yes. 10. Oh, I've been writing P2. Those are P6. Sorry, it's not always 2. It's however many are there. So then we have 3s2, 3p6, 4s2. There we go. Because P can hold 6. Then 3d can hold 10. And then we're back to the 4p block, which has all 6 full. Then we have 5s2, 4d to the 10, 5p to the 6. It's not to the 6, whatever. All right, and that puts us at xenon. Okay, that's where 5p to the 6, or goodness, 5p6 takes us. Okay, so then we have 6s2. All right, and I'm going to put a slash right here because that's where xenon was. Okay, you wouldn't normally put a slash, but I'm putting there for demonstration. We have 6s2. Okay, from here, we have 5d. Oh no, before that we have the f block here. So we have, let me see, minus 2, so it'd be 4f. I want to say 14. I had it somewhere. Oh, there we go. 14. Yep. Could have counted, I guess. All right. So 4F to 14. Then we have the 5D block, which has 6. Then I have 2 in the 6P block, so 6P2. Okay, that was lead. Again, it's not hard. It's just a lot of writing. Okay, but there is a shortcut, so let's use the shortcut. Let me show you guys the difference. Okay, and let me get, all right, well, let's just do this. All right, so that's the long way. With the shortcut, however, I can just say, all right, xenon, everything's the same up to that point. Then we have, starting there, 6s2, 4f14, 5d6, and 6p2. Okay, and that would be our abbreviated notation because the noble gases are understood up to that point. Okay, so if that feels kind of like a hack, it kind of is, but it's a shorthand scientists have come up with to better demonstrate how this works, because once you're at a noble gas, you know everything's the same up to that point. It saves a lot of writing. Okay, so that's how we do that there. Real quick tip, especially as you guys are getting used to this, you won't have this resource on your test or your quizzes, so keep that in mind. Okay, however, ptable.com is, again, I can't recommend this thing enough. If I click on electrons, actually let me go ahead and go dark mode, full screen, and here we go. If I go electrons, and I hover over lead, it will actually tell me, notice this thing is now color-coded by block, okay? So the S block is in this teal. You have the D block in this pink. You have this P block in this green, and then this dark blue is the F block, okay? And so they'll have it by that, but not only that, if I click on lead, you'll notice it actually tells me where all my electrons are. And so I have 1s, or 1s2, because there's 2 in there, 2s2. I know this is kind of small, but just bear with me, okay? You have then 2p6, then 3s2, then 3p6. Then you have 4s2, 3d10, there we go. All right, and so on, okay? So you can tell we're here. And if you look over here, there's its configuration. Okay? If you want the expanded form, it will tell you the complete expanded form. Now you're like, sweet, that saves me so much time on my homework. You know, you can. I mean, it wouldn't bother me. However, if you don't know how to do it, you're going to be stuck come the test. Okay? So you guys need to know how to do this without using the computer. However, you can look it up and see if you're doing it correctly. Okay, and notice our quantum numbers here. They do actually tell us that. So I think that's based on which thing I click. So like if I click here, yeah, it'll actually show you the shape of that orbital. Okay, so just in case you guys are wondering what it looked like or what the F orbital looks like, you can tell that that's, okay, you get some interesting shapes down there. So again, it's a really cool thing to play around with. And this is all well and good, and it's very useful. However, it's not as useful as you might think. Because turns out most of chemistry happens in just the outer shell, okay? And the outer shell, keep in mind, only the S and P blocks are ever shown on the outer shell, because before the D and F blocks get full, the next S block gets filled. So S and P shield the rest of the electrons. So we're only going to consider the S and P subshells in practice. Oops, I need to go back here. Okay, and we're going to do what's called Lewis symbols, and these allow us to just look at the valence electrons, again, just those electrons in the S and P subshells. At most, there are only 8, because that's all that can fit in S plus P. 2 plus 6 is 8. Okay? And so this allows us to use valence electrons. And in order to do this, we use what's called a Lewis symbol, also known as an electron dot formula. And this is a representation of the valence electrons as dots around the chemical symbol. Now, you don't put the numbers here. Okay? The numbers are here to show you in what order to fill them in. Okay? So this is talking about when we're not trying to combine elements. We'll talk about their bonding later. But when we're not trying to combine elements, then when we're just writing an element on its own, there's actually an order. And so you'll notice we fill in the s orbital first. Then we fill in 1 in each direction of the p orbital. And then we come back around and fill in based on that. Okay, so that's the idea here. So let me take and let me see here. I think that might have actually... Okay, I have something about... What? Oh, this is talking about lasers. Okay, we'll get to that in a minute. Okay, I can't remember what my slides are half the time. All right, so let's take this lead. Okay, we're going to use the same example, but now I'm only concerned about the valence electrons. Okay? And you might say, well, this is so much simpler, why do the other one? Because sometimes we need to know all of them. Okay, but again, for basic chemistry, not so much. So for lead, we need, I would just write Pb. I just write its atomic symbol. Okay? And then I'm in the 6th row, so I'm only going to consider stuff in this S and P subshells. So both of the S ones are filled, so I'll fill that in. And then only 2P are filled, so I do 1, 2. And that is the electron formula, dot formula for lead. Now that may feel frustrating after looking at the entire electron configuration. You're like, wait a minute, hold on. We did, yep. Okay. This is actually a much more useful form to us on the everyday. Okay? This is for the nitty-gritty. Okay? So that's really the idea. Okay? Now, if I were to, let me just show you guys, if I were to do iodine, okay, let me just do this off to the side here. Okay? So we have iodine, and then I would do 1, 2, 3, 4, 5. Okay? And I'm at 1, 2, 3 here. I'm only at this point right now. So then I start filling in here and here, but not here because that would be xenon, okay? Or that would imply that this is neon, and we don't have that, okay? So hopefully that makes sense with electron dot configurations. Those are quite a bit simpler. You can see all the Lewis symbols of the elements there on page 110 of your textbook. And again, we don't often care about the whole thing. I do want to point out a couple things on this periodic table. So I'm going to close this and actually open up the PDF because that'll be a little clearer for how much I want to zoom in here. All right. Yeah, I don't need this anymore. Okay. Just making sure before I close it and not save. Let me open up. Let me get out of this. And this. Oh, it's F11 in Chrome. All right. Let me open it here. Chemistry, periodic table. Really? Oh, goodness, and the bar isn't even where it's supposed to be. Okay, here we go. Okay, so I'm going to zoom way in. If it will let me. Okay, fine, I have to do it the other way. Whatever. All right. If I zoom, a little too far. All right, if I zoom way in, okay, you'll see these little dots, okay? This tells us how many electrons are these little dots. You'll see these little numbers, okay? For example, nickel. And I know I've blown this box way up, but you can see it easier in print than you can on screen, so I'm blowing it way up to make it really easy to see. We have here, it's not the whole electron configuration, nor is it the Lewis dot symbol. However, it tells you how many electrons are in each level. So in the first level, there's 2. In the second level, there's 8. In the third level, there's 16. And in the last level, there's 2. And now we're in the transition metals, so there's a lot of funkiness that happens here. But let's look at, and sorry, this is not going to be smooth scrolling, iodine for just a minute. Okay, if I look at iodine, no. Okay, well, I just won't save changes. That has a D in there. Okay. And you'll see it's labeled KLMNOPQ. That's the energy sublevel you're at, okay? Or sorry, energy level you're at. And we start numbering that at K. But anyway, moving on. This would be our 1, 2, 3, 4, 5th energy level. So that's all those letters mean. They're labeling these numbers. And so in iodine, you'll notice if you look at your bottommost number, that's your number of valence electrons. And so that'll help you out with your Lewis dot formula, okay? Xenon, you'll notice, has 8. And as a matter of fact, if you'll notice, all the noble gases have 8 as their last number, okay? Except helium. Helium's the exception. Again, it's a lot of exceptions. We're going to move on from that. All right, so that's the idea of the periodic table. So that's multiple tools you have to know how many valence electrons, to know what all is going on there. And I'm going to close this without, hopefully that didn't save anything. All right, but let's go ahead and go back to this. All right, in your box on page 110, we start talking about chemical layers and lasers. No, it's not baking. Chemical lasers and energy levels. Now, ordinarily, an electron in an excited state or higher energy level will quickly drop back to a lower energy state and emit a photon, usually within a fraction of a second. However, Albert Einstein predicted in 1917 that if the atom is struck by a photon of the correct frequency during this brief excited state, something different happens. Instead of just emitting one photon, the electron instantly emits 2 identical photons as it returns to the ground state, a process Einstein called stimulated emission. Over 40 years after Einstein's bold prediction, an American scientist named Theodore Maiman successfully harnessed stimulated emission to produce narrow beams of high-intensity light. Maiman named his invention a laser. Since 1960, lasers have found a tremendous variety of uses, from DVD players to eye surgery. We've refined them so far now that you have Blu-ray and 4K Blu-ray, which is just an extra dense disc. You have, there may be more compression on Blu-rays or on 4K Blu-rays. Don't quote me on that. But anyway, I know Blu-ray itself is a refined laser. You know, we use it to everything from cutting metal to reading discs to transmitting information. If you have fiber to the home, where, say, for example, if you have Frontier and there's a fiber box and then they send it to the rest of your network through regular copper, that's actually sometimes using lasers. And I have to be really careful because sometimes companies will cheap out and use LEDs, which the technology has gotten good enough where over shorter runs, that's fine. But most of the fiber runs for telecommunications are laser, but that's as far as I'm going to take that. Because for all I know, Frontier is shipping out and has LEDs. I really don't know. Haven't looked into it. Probably should. But anyway, moving on. Either way, I get fast internet. I don't care. Okay, but on campus, we actually have a fiber run between the main building and the first modular. Now, the rest of the modulars are connected after that with regular Cat6 cable that underground. Okay, but we have a fiber run from main building to the first modular because the first modular then has all the runs to all the other modulars. So we wanted to make sure 2 things. First of all, that we wouldn't be bottlenecking everything by going through the first modular, okay? And then the second reason, and more importantly, is that in the unlikely event of a lightning strike, we didn't want it taking out the switches on both sides, okay? Because glass can't transmit electricity. So that's why we did that, is more to protect the equipment and more to keep from doing that. But the fiber optic cable you have to use for that is extremely fine and delicate. And we actually had to have a specialist terminate that so we could use it. Okay, and so that's even out of like something I can't even do. And even Aaron Brandt, those of you who remember him, he passed away recently. And he was a tremendous help with our networking. And even he didn't do it. He had his friend come in who knew how to do this thing, and he did it for us. We did the rest of the work as far as that goes. His friend and him ran all the Ethernet lines as well, but then him and I took care of the configuration, terminating things. Admittedly, it was mostly him, but moving on. It was a great help to us, but the technology there, that fiber, I think we're actually only using LED because LEDs have just gotten that productive. But the origination of using fiber optics actually started with lasers. It's one of its most common applications. If you've ever looked behind your computer or behind your Whether you have a soundbar at home or your TV, there might be a little box with a little red light behind it. Now, in most modern electronics, that'll actually be an LED. But it used to be those were lasers, and it would send optical signals, with audio, so that you wouldn't transmit electrical noise. It would only transmit the audio because it can't conduct electricity. So it's really useful for things along those lines, but man, have I sidebarred, so let's get back to this. Now, although Maimann's laser produced stimulated emission by exciting chromium atoms in a ruby crystal with a flash lamp, many modern lasers use electrical or chemical processes to create excited states. For example, the common argon fluoride excimer laser, used in vision correction surgery and computer chip manufacturing uses electrical discharge to bump one of argon's 3p electrons up to the 4s level, temporarily giving it the same valence shell electrons as potassium. Like potassium, excited argon can donate its outermost electron to fluorine, forming ionic argon fluoride. This short-lived molecule undergoes stimulated emission, producing a brief pulse of UV light. Now, I don't know if this is actually one of those lasers or not. It's just a laser. So, yeah, anyway. Some of the most powerful lasers use highly exothermic chemical reactions to produce excited state atoms. One design tested for military use burns ethene and nitrogen trifluoride in a rocket-like combustion chamber to produce excited fluorine atoms. An isotope of hydrogen called deuterium, where it's got, and it's not just a proton, it's a proton and a neutron, and that's very weird for hydrogen. So that's why it has its own name, is injected into the supersonic exhaust stream to produce excited deuterium fluoride, which undergoes intense stimulated emission in the mid-infrared. Such lasers have successfully destroyed various targets in flight. That's actually part of, okay, I don't know if it currently is, but at one point it's my understanding, and I'm going to be very careful how I phrase that, that's actually part of America's Star Wars defense program. Whether or not it still goes by that name, I actually don't know. I just know it was for a while. But that's actually how they're trying to knock out, or trying to get the capability to knock out missiles in flight. It's a lot harder than it sounds. And an even more advanced design is the chemical oxygen iodine laser, often abbreviated COIL, which burns hydrogen peroxide and chlorine to produce excited oxygen, which then reacts with an injected iodine gas to form an excited iodine that undergoes stimulated emission. Aircraft-mounted COIL systems have been tested for use in missile defense as well. Okay, and that's just the reality of it. You make something, and even if you mean something to be, great, anything that can be used in peace can be used in war. That's just the reality of it. Okay, so we can't knock progress for the sake of progress. Okay, we can knock maybe our treatment of fellow humans, but that's beside the point. All right, that's the end of chapter 7, because I'm going to just completely stop talking about that before I get myself in trouble. And yeah, that's basically it. That's the end of chapter 7. So the main things here is you need to work on knowing how to do electron configuration. You need to know how to do Lewis symbols. You need to look at where you are with shell, subshell, and then you have the other two quantum numbers giving your magnetic quantum number and your spin. I feel like I just said something wrong. Nope, that's right. All right, and that's basically it. So that's 7.3. 7.3 is fairly dense, so make sure you guys study pretty hard on it. Make sure you guys do your work on it. Again, tomorrow you guys will have a work day. Those of you here in the Distance Learning Center can ask me questions. If you're a remote learner, you can go ahead and email or text me any questions, and I'll see you guys later.
Hey guys, let's get started for today. Pull out your handouts for your grammar. Your grammar handouts, turn to the adjectives. Okay, pull out a highlighter. Make sure you highlight what an adjective is. There it is in our slideshow. Adjectives are words that modify a noun or a pronoun. Yesterday we kind of reviewed on, give me one second. Yesterday we reviewed on what a noun was, what a pronoun was, and what a verb was. Okay, a noun is a person, place, thing, or idea. A verb shows action or existence, state of being, it links. And then pronouns are words that don't exactly, it's a word for which a pronoun stands, or a noun stands. And it's kind of like he, she, we. It doesn't name a specific common noun or specific name of a noun. It's just the word for which a noun stands. Okay, that is a pronoun. Today we're going to review adjectives. Go ahead and take out your notes if you haven't already. Those of you on distant learning, please comment that you're here and let me know so I can mark for your attendance today. Okay, adjectives are words that describe or modify a noun or a pronoun. So these adjectives answer the questions which one, what kind, how many, how much, and whose. Okay. Examples of adjectives: yummy food, what kind, which ones, those shoes. Okay. 7 days, how many days, 7. How much grace, abundant grace. Whose computer, his computer. Whose book, Billy's book. Okay. Those are examples of adjectives, and those are examples of the questions that those adjectives answer. Okay, there are proper adjectives. These proper adjectives are a word or word form from a noun or a proper noun or a proper noun used as an adjective. Okay, these are proper adjectives. The proper noun is Hawaii. The proper adjective would be Hawaiian. The proper noun is Christmas. Proper adjective would be the Christmas program. What kind of program or which program? That is an example of a proper adjective. We saw that the articles a, an, and the, these are always used as adjectives because they're describing which object. So the object, a object, an object, okay? Articles used as adjectives. The indefinite article a and an refer to someone or something as merely one among others of the same class. So if I'm talking about a group of chairs, okay, I always use chairs as an example, if you'll notice, because there's a bunch of chairs in front of me. So sorry if I'm using chairs a lot, but there are a bunch of chairs in front of me, which is why I use chairs, okay? So if I take a group of chairs and I'll say a chair, it's not exactly referring to a specific chair, okay? That is the indefinite article. It points to something or someone as merely one of others, okay? The definite article, the, refers to specifically to something or someone as distinguished from the other. So I'll point to the chair. That is indicating what chair I'm talking about. So it'll be the chair, and a chair is randomly a chair in a group of chairs, okay? Those are the differences between a, an, and the. Make sure you use a for words that begin with a consonant sound, and the word an for words that begin with a vowel sound. Notice that they're not beginning with just a vowel, okay? It's a vowel sound. For example, hour, H-O-U-R, hour. Okay, so I would use the word an even though it starts with the letter H because it has a vowel sound of an O, okay? Watch for that. There are participles and infinitives. We haven't exactly gone over those yet, so you may have to watch for these participles. It's a verb form used as an adjective. Cheering section, that's kind of what kind of section or which section it is. We said that verb forms used as adjectives are called participles. A verb form is if it's ending in ing. It's an action, not an action, but cheer is an action. Cheering is a verb form used as an adjective. okay? Or a noun, depending on its function in the sentence. Infinitives is always to plus the verb. That is an infinitive. Those also can be used as an adjective as well as an adverb. So make sure you're looking at to what that phrase is describing. If it's describing nouns and pronouns, that to beat or that to plus the verb form, which is an infinitive, that will be describing a noun or a pronoun that's used as an adjective. And then if it's describing a verb, an adverb, or an adjective, that infinitive will be used as an adverb. So watch for those, okay? Adjectives answer which one, what kind, how many, how much, whose. They modify nouns and pronouns. Adverbs are words that modify verbs, adjectives, and other adverbs, and they answer the questions where, when, how often, to what extent, okay? We said these, we keep saying these over and over and over again. A lot of the times they'll modify verbs. Most of the time they do modify verbs, so make sure you're looking to see what exactly it is modifying within that sentence, whether it is the verb or an adjective or an adverb, okay? Adverbs examples, they go everywhere together. Where do they go? Everywhere. Everywhere is describing go, because that's where they go. She always arrives early. When is telling us when she arrives, which is early. Always arrives. Always is going to arrive, always is going to arrive, so that is your adverb. He drives carefully. Carefully is going to drive. Drive is a verb, therefore carefully is an adverb. Okay. She goes to the store periodically. How often does she go or goes? Periodically is going to goes. Okay. That is asking or answering how often does she go. Okay. Then lastly, today is terribly hot. Terribly is going to hot. Hot is a predicate adjective. Therefore, terribly is an adverb because that is describing hot. All right? Adjectives, adverbs, let's talk about prepositions. Prepositions are words that show how a noun or a pronoun is related to some other word in the sentence. Remember how we said this kind of links the subject to the verb, or what the subject is doing to an object, different things like that. For example, the coconut was high above our heads. Okay? Above our heads is showing relation between the coconut and high, or where it was. Okay? Above our heads is your preposition, and it's showing the position of the coconut, which is above our heads. Okay? Next, we walked across the street. Across the street is showing the relation between walking and us. It's telling us where we're walking, so it's the direction we're walking across the street. We ate dessert after dinner. After dinner is showing the relation between we and ate, or when we ate dessert after dinner. So that's telling us the time. Okay, we have a coffee maker at work. We have a coffee maker where? At work. That's showing us the location of where we have the coffee maker. Okay, hopefully those make sense and you can see the differences between those. Let's look at conjunctions. Conjunctions is a word or a group of words that joins words, phrases, or clauses. Okay, we saw that the words and, but, or, nor, for, and yet, or so are coordinating conjunctions. Those words join phrases, words, and other clauses of equal grammatical rank. Okay, we saw that equal grammatical rank means that it's an independent clause to an independent clause, a word to a word. Okay, that's equal grammatical rank. Unequal grammatical rank would be subordinating conjunctions, and therefore it would be joining independent clauses to dependent clauses. And then those start with as long as, although, as if, as much as, whenever, whether, since, okay? Obviously, subordinate conjunctions aren't limited to those exact words, just like and, but, or, nor, for, and yet aren't. But and, but, or, nor, for, and yet are your most common type of coordinating conjunctions. Subordinate conjunctions, you just kind of have to look at it and say, okay, this is linking or joining an independent clause to a dependent clause, or a dependent clause to an independent clause, and therefore it is a subordinating conjunction. So as long as, although, as if, One word that's not on your list is the word because, okay? So different things like that you need to look at, okay? Those are just kind of what explaining for, but, yet are. Those are examples of those words. Coordinating conjunctions. Like I said, subordinating conjunctions can be a huge list if you want it, but make sure you guys are looking at its function in the sentence, okay? One more thing, independent elements, okay? Independent elements won't be on your quiz, so let's go ahead and move on. We did talk about interjections, direct address, parenthetical expressions, nominative absolutes. Okay, but here is your review for test 1. Okay, if you guys have a paper and a pen or a highlighter in your notes, whatever, or like you can even highlight in your handouts. Okay, you can even highlight in there what is going to be on your test. Okay, so make sure you identify the parts of speech in a sentence you know how to. Okay, know how to identify a verb. Know how to identify a noun, pronoun, adjective, adverb, preposition, and conjunction. How to find that, okay? So verbs, they show action or state of being. Nouns, these are people, persons, places, things, or ideas, okay? Chairs, door, cabinet, shelf, backpack, those are nouns, okay? Pronoun, he, she, we, they, it, okay? Those are a word that takes the place of a noun. Adjectives, remember we said they modify a noun or a pronoun. Which one, what kind, how many, how much, and whose. Shows you whose backpack, whose water bottle, what kind of dresses, what kind, how many carts, computers, whatever, okay? Those questions help you identify adjectives and help you tell the difference between adjectives and adverbs, which are words that modify verbs. Adverbs are adjectives. Adverbs answer the questions where, when, how often, to what extent. So how often do they run? Where do they go? Go, run, those are verbs, okay? Make sure you know the differences between those. Prepositions, a word that shows how a noun or a pronoun is related to the other words in the sentence. Those are inside the room, beside the table, outside the door, okay? That's kind of showing where we are in relation to the door, okay? It shows me where am I in relation to the room. I'm inside the room, next to the door, beside the table, okay? Those are prepositions. Lastly, conjunctions, they join words, phrases, or clauses, okay? Words, phrases, and clauses, that's pretty self-explanatory. Word and word. Peter and Piper, okay? So, and is your conjunction joining Peter and Piper. Make sure you look for those in independent clauses that can join those two, okay? Next, know identifying complements within a sentence. Know how to find the direct object, the indirect object, the objective complement, and then know the differences between finding the direct object and a predicate nominative. Remember how we said direct objects, indirect objects, and objective complements go with action verbs. Predicate nominatives and predicate adjectives go with linking verbs, okay? Predicate nominatives rename the subject. Predicate adjectives describe the subject, and they only go with linking verbs. Direct objects, it's receiving the action of the verb, the action verb, who or what did this. So I taught who or what? Class. Class is my direct object. So different things like that. Make sure you guys are studying how to find those. If you have any questions, please ask. I'll be happy to show you. But don't just sit there on test day and just say, I have no idea how to do this, and then fail everything. So make sure you guys are asking me, okay? Go ahead and put those away. That is for your quiz or your test tomorrow in grammar. You also have a literature test on Friday, which we already went over and what's going to be on it. So make sure you're studying that as well. Obviously, it's Wednesday tonight, so there's no homework for that. So make sure you're studying, preparing for this week's test. Okay, go ahead and take out your spelling books. Okay, we're just going to do this quickly right before we take our quiz in literature. Okay. Last week, you should have done your words already, your vocab words, twice. So make sure you guys are studying that. No homework tonight, Wednesday, but let's look at our words, okay? We are on vocabulary list number 2. Okay, look at number 1. It is efface, or efface, okay? Not efface, efface. A-C-E, obviously that is the long word of the A. It's not efface, it's efface, okay? It means to erase or remove something as if by rubbing. So an eraser, efface, E and E, erase, efface. I don't know if that helps you. It would help me, so that's what it means. Number 2, egregious, outstandingly bad. Okay, number 3, emanate, to flow forth or originate from a source. Number 4, exemplify, to illustrate something by acting as an example. So example, exemplify, pretty self-explanatory. Exorbitant, going beyond what is reasonable. Excessive, exorbitant kind of sounds like an excessive word. So exorbitant, excessive, things that kind of will help you link words in your mind together. Extenuate, to lessen the seriousness of the circumstances by giving excuses. Excuses, extenuate. Number 7, imbibe, okay, or imbibe. I'm so blind today, I'm so sorry. Imbibe, to drink, to absorb, or take in with the senses as if by drinking, okay? To drink, imbibe, I don't really know how you can link those two together, maybe the clues in your mind, but imbibe means to drink, to absorb, or take in with the senses as if by drinking. Incarcerate, to imprison, that one's kind of easy. Indemnify, to protect against or compensate for damage or loss. Insipid, without excitement or appeal. Intrepid, fearless. Inundate, to cover with water, to overwhelm as if with a flood. Okay, I don't think these will be too hard to understand or too hard to remember because a lot of these words sound like their definitions. But hopefully you guys have been studying that. Your quiz will be next week not next week. Your quiz will be on Tuesday, the October 13th. So not next week. We will be working on our roots, prefixes, and suffixes. Go ahead and turn over to page 17. Look at our prefixes. Ex means out of, away from, or without, intensive. There are 2 different ins. One obviously is in 2. Another one is in, which means not, okay? That last one, sin, it means with, together. So like maybe you can think of synonymous. If you're synonymous, it means like together or you're with somebody. Look at your roots. AG or ACT, ag or act. That means to do, to drive. Bibli, book. That's kind of a good indicator because we think of bibliography. That's a book. Different things like that. Cap, capped, sept or sip. To take, to seize. Clyn, to lean, to slope. Or we can think of that as the word clyn in the word incline. So incline or decline. Clyn means to lean or to slope. Fid regards faith. F and F, gen, gent, birth, race, kind or cause, generations, different things like that. Ped, foot. Tract, to draw, to drag. Okay, attract, to draw, to drag, different things like that. Suffixes ending in ent, one who, that which. Number 2, like, pertaining to. Okay, so if you have the words ent or ent1, you can say one who, that which, or you can even say like, pertaining to. They both mean the same. Just depends on your root word and what that suffix is on the end of. Okay, ment means that which, state, quality, act of, and E, which is the state, quality, act, result of. All right, no homework tonight in vocab, but make sure you're studying those. Your quiz will be on October 13th. And then today will be our literature quiz. Okay, so let's go ahead and review for that really quick. Okay, make sure you know what the short tale or an anecdote to teach a story is. Who wrote the Canterbury Tales? Where the pilgrims were heading on their journey. Okay, know some characters from the Canterbury Tales. Know the Partner's Tale and who were the three men seeking to kill. Know what they found instead. Know what the moral of the story is in the Partner's Tale. Know what the work or which work that remains an outstanding monument in English literature and who wrote that work. And in this work, what did Sir Bedivere cast into the lake? Hopefully that one's pretty easy. We did go over it yesterday and 2 days before, so hopefully you guys studied for this quiz, okay? Go ahead and look over that for a few minutes while I walk over there. Christian Cormel and Christian Halsey, I sent them to you through email, and then Christian Cormel, I think I sent it to your mom's My School Works. So hopefully you guys can get that and then send that to me as soon as possible.
All right, welcome to Algebra 2. I did adjust the volume up here, so if it's a little loud where you are, sorry about that. This should be fixed now. I'll mention it. The same button has been pressed on all three mixers, so I'll mention something in staff meeting today, so that way we're all broadcasting at the same volume. But anyway, in the meantime, we're talking about division of radicals. So we're on page 53. We covered the first part of 1.8 yesterday. And so today we're going to go through the division of radicals. Now, radicals should not be in the denominator of an answer, so we need to rationalize any denominators by making the denominator a perfect root. If the denominator contains a radical as part of a binomial, multiply both the numerator and denominator by the conjugate of the denominator. Radicals with fractional radicands also need to be rationalized because the root of a fraction can be rewritten as the root of the numerator over the root of the denominator. Okay, so let's go through and look at example 1.8d. So we have example, let's go through and make that a little. So we have example 1.8d. All right, so looking at part A, we are told to divide. I've got to zoom in on that. All right, we have the cube root of 2 over the cube root of 9. And so the goal here is to completely remove the radical in the denominator. Now, the first thing I'm going to note is that the cube root of 9 is the only problem. We don't care about the cube root of 2. That can live there. Okay? So instead, what we're going to do is we have the cube root of 2 over the cube root of, notice this is 3 squared. Okay? Now, if you didn't notice that, that's fine. It just means you're going to end up with a much larger thing that you have to reduce later. So this is the cube root of 3 squared. So to fix this, we're going to take the cube root of 2 times the cube root of 3 all over the cube root of 3. We're going to fill in whatever is missing to make the denominator not have a radical. So we need to get 3 to the third power. Okay, so we have the cube root of 3 over the cube root of 3. Okay, and so when we multiply, we're going to get that this is the cube root of 6, because they're the same index, we can just multiply, all over 3. Okay? The book also shows this being written as 1/3 the cube root of 6. I really am not a fan of writing fractions that way, so that's personally, I'll leave it over 3 instead. All right, let's look at part B. Again, this is in your book, so I'm just going to go ahead and continue on. We have the square root of 1/5. Well, if you'll remember from our properties, it's the square root of 1 over the square root of 5. And so the square root of 1 is 1, so that was easy. But the square root of 5 is definitely an irrational number. So I'm going to go through here and multiply both the top and the bottom by the square root of 5. And so I'm going to get the square root of 5 over 5. Okay, or again, 1/5 the square root of 5, but again, that's not personally how I like to do it, so I'm not going to do it that way. All right, let's look at part C. I'm going to see if I can make this a little thicker. There we go. That's probably a bit more readable. We have x over 4 plus the square root of 6. So we have a radical down there, but it's not something that I can easily take care of. So what I'm going to do is I'm going to go through and multiply by the conjugate. If you don't remember, the conjugate means you have the same first and last terms, but you switch the sign in the middle. And what this will do is it will help me when I go through and multiply, it will remove the middle terms. Okay? So I'm going to multiply the top and the bottom by 4 minus the square root of 6. Okay? And so then this is going to equal, when I go through and multiply the top, I'll get 4x minus x times the square root of 6 all over. And the book shows the in-between step. But first of all, we have 4 times 4, which is 16. Okay? And there it is. Okay, we have 16. Then we take 4 times negative square root of 6 plus 4 times positive square root of 6. And those two will go away because 4 minus 4 is 0. So we'll end up with 0 times the square root of 6, which means it goes away. I'm not going to bother writing it. Square root of 6 times negative square root of 6 is negative 36. No, it's negative 6. Durr. It's the square root of 36, which is 6. I just wrote both things at the same time. So then, at this point, what we can do is we can go through and say then that I have 4x minus x times the square root of 6 all divided by 10. Okay, and that would be my final answer. Now, there are times that where the denominator will just go away, and we call those being really lucky. Anyway, if I have, there's my cursor. If I have the square root of 12 over the square root of 4, for example, this isn't part of the example, I can combine this again to say it's the square root of 12 over 4. Well, 12 over 4 I know is 3. So I end up with the square root of 3, and that's simplified. So always be on the lookout for a fraction you can reduce. We can always recombine, we can decombine, we can do what we need to do to get all this done. So let's go ahead and get on to example 1.8e. So in example 1.8e, part A, we have the cube root of 20x over the cube root of 5. Okay? And so we get the cube root of 20x over 5. And again, we do this because 5 can go into 20 evenly, and so we get just the cube root of 4x. Okay, it won't always work out like this, but when it does, take advantage of it. Okay, that's simple. Part B, we have the square root of 32y over 10. Well, I can reduce at least, and so that will give me the square root of 16y. Oh, nope. Wait. Hold on. Why does the book say 17? What in the world? Like, I'm not crazy, right? 32 divided by 2 is 16. Okay, well, I'm going to do it anyway. So it's 16y over 5. Okay. I don't know. Where's my eraser? All right. So let's get rid of that. And here we go. Okay, so we have 16y over 5, which means that I have the square root of 16. Y, so I have the, oh goodness, I have 4 times the square root of y over the square root of 5. Now your book shows you just multiplying it there. You can just go ahead and do this separate, just like we would normally. It doesn't matter to me, but we already know how to do this, so let's just keep doing it. So this gives me then 4 times the square root of 5y all over 5, okay? And that would be what we get. I know it's different from what the book says, but that's because 32 divided by 2 is definitely 17. I don't know what else they're doing there. Okay, so there you go. That's your examples. Not tonight's work, but Thursday night's work is your practice 1.8, numbers 33 through 56. 33 through 56, green. Green. Okay? Now, oh, right, you guys were supposed to have a quiz today. Yeah, we still got time. All right, so you guys will take quiz 4 once I get down there, and then tomorrow will be a work day for practice 1.8. So you guys will have quiz 1.4 here in just a couple minutes, and then you guys will be practicing tomorrow 1.8 with that. Now, really quickly, let me just go through this, and I know that you all just are like, you have a quiz, get down here. But give me just a minute, and let's go through important dates coming up. Add a page, add text, and here we go. So Friday, whoops, you have, nope, 1.8 day 2 due. Okay, let's widen this by a lot. Okay. And then Monday, you will have chapter 1 review due. On that one, green ones are assigned, non-green ones are bonus. I'll give you guys more. Well, actually, that's basically it. Okay. Chapter 1 review will be tomorrow and Friday, well, more Friday night's work. But I'm letting you guys know about it now because it can be quite heavy. So Chapter 1 review, you have the green problems assigned, non-green problems bonus. Okay. And then, finally, you guys have tests on Monday, Tuesday. You guys have test 1 over Chapter 1. Actually, no, we're going to change that. And we're going to change this to Tuesday, Wednesday. So that way I've got a day to go over your chapter review. Okay? So that's your important dates coming up. Make sure that you guys have that. And again, prepare for quiz 4 over 1.7.